We'll proceed in pseudo multivariate calculus. Pseudo multivariate calculus in which we are pursuing the discussion. Pseudo multivariate calculus. Can we write a can we solve a mathematical problem in pure numerical fashion? Multiplication, division, subtraction and addition, and then slowly we will come to calculus. That is the concept. In that concept, we are in phase of calculating the energy. Energy is force force into displacement. What is energy? Energy is force into displacement. Okay, so if this is the object and this is the force means my body is imparting energy now. Like this force is because of this force, this item is moving. Okay, how much this item moved? This is displacement. And how much is the force through my hand? If I multiply force with the displacement, then it is the energy that my body has lost, making this item move from here to here to here. Force into displacement is the energy. Now next comes is that if force and displacement, they are not in the same direction. Okay, for that we took example like, okay, we took example like where that went. Okay, so okay, so this is the path of displacement. This is the path of displacement, and this is force. After all, force will be applied in one path. So I'm applying force in this direction. Let's see. I'm applying force vertical, exactly vertical, but displacement is happening along this path because it is forced to move in this path. And in that sense, even though it is like this, displacement is happening. Displacement is happening. I'm making force upward like this. This displacement is not possible if I make the force 90-degree to the displacement. If I do give the force like this, no displacement. If I make little angle also, then there will be little bit displacement will be there, little bit angle. Okay, if it is completely perpendicular, then no displacement. Okay, so force into force, what, how much is the force and how much displacement it is moving into the angle between force and displacement. Right now angle is 90 degree, so there won't be any displacement. Now angle is 0 degree, there will be full displacement. Okay, that is 0 degree. So first is, what is energy? Energy is force into displacement. If force and displacement, they are not in the same direction, then force into displacement into cos theta. That is the angle between force and displacement. Force into displacement into cos theta. That is the net energy that is involved in making this item move. If I have a force, if I applied force from my body and force and displacement are in same direction, then energy is more, means that it will move nicely. If force I apply from my body and it is at 90-degree, even though I am trying to place force, but net movement is zero. Means net work done that this guy is showing is zero. Means I am not losing energy. When this is not moving at all, I'll just try to put force, but it has to move. Then only I will start losing the energy. How much energy I am losing is force into displacement into cos theta. Okay, that is the idea. Now, people know that this is number mathematics. What is force? Force is 3 Newton. What is displacement? 2 meter. What is the cos theta? 60 degree. What is cos 60 degree? Calculate. How much it moved? How many meters? Calculate. And what is the force that is involved, Newton. Just multiply all three. That is the energy involved when it moves. Okay, it is all right. So this is called energy calculation. Now, instead of cos theta, I'll proceed as force vector dot product with the displacement vector is the energy. Slowly we are moving. Now, in that sense, force vector, I'm sorry, I'll little bit go back. Force magnitude, displacement magnitude into cos theta is the energy. What is displacement magnitude? What is displacement magnitude? Displacement magnitude is from one location to other location. How much is the distance is traveled? Repeatedly, we are showing the distance may not always be a straight line. Distance can be curved line also. In that sense, curved line it is traveled is because of this force. This is traveling in curved line. Okay, in that sense, what is the length that it travels? Now it is difficult. The length it travels into force into cos theta is the net work done. Now force field is like this, and when it is traveling at this moment, cos theta is angle with this the tangent at this point. When this is at this point, what is the tangent at this point? This is the tangent at this point, and force is in this direction. What is the angle between them? That is cos theta. Now, in that sense, if I make it move at this point, tangent is exactly in parallel to the force. Here, it will slide faster. Then it is rotating like this. Every moment, it is different. So, now it comes as vector. Okay, we cannot do like force. What is your force? This is my force. What is displacement? Then this is the displacement. What is the cos theta? Cos theta is varying now. Cos theta is not constant. Every moment, this cos theta with the line, with the angle, if force vector is straightforward, but cos theta, here the cos theta is like this. Cos theta is varying. Now here, how we can tackle this problem? The idea is write the code the way you write the code someone writes in a pseudo fashion. Pseudo fashion is force vector dot displacement vector is the net work done. Force vector I know dot displacement vector I don't know. What is your force vector? Consider force vector is xi plus yj. Xi plus yj. Xi plus yj means force if this point is origin, then force vector is radial. This is force vector. If item is moving along x-axis, force vector will be applied along x-axis. If item is moving along, if item is kept here, vector will be applied like this. Force vector will be applied like this. Here, force vector will be force vector is in this direction. Along x-axis, it is along x-axis direction, xi plus yj. Y is 0 along x-axis. Only xi will be there. If it is like this, then force vector in the force vector is not constant. If I say force vector is I plus j, if this is x-axis, this is y-axis. This is x-axis, this is y-axis. I plus j. Force vector is like this. Everywhere force vector is like this one. It will not change. It's a constant vector. But if force vector is xi plus yj, then force vector will keep changing. Now, this force vector is along x-axis, it is in x-axis direction, xi plus yj. Along y-axis, x is 0, yj. Otherwise, it will be radial. Here, if I take a point 1, comma 2, this is 1, this is 2, 1, comma 2, force vector will be like this. If I take point 2, comma 1, force vector will be like this. If I take point 0, comma 1, force vector is changed. That is xi plus yj. Consider force vector is xi plus yj. And distance in which direction item should move. Item should move in this direction along a line because I have pierced this the item to move inside this. Now this will certainly it will always move like this only. What is the equation of this? This equation of this line is y equal to x square. Now calculate the work done. Okay. The idea of pseudo multivariate calculus is algorithm is same. Force vector dot displacement vector is the network done. Force vector I know xi plus yj dot displacement vector. Displacement vector is changing every moment. What vector I take? If I take at this position, displacement vector, then this is like this. If I take this position, the displacement vector is like this. If I take this position, displacement vector is like this. If I take at this position, displacement vector is like this. Everywhere displacement vector is changing. Everywhere displacement vector is changing. Which vector I should take? Like force vector is also everywhere it is changing. Okay, in this scenario, people would die. What to do now? I knew if force vector is I plus j and displacement vector is I plus 2j, okay, then I plus j net magnitude is square root of 2. I plus 2j net magnitude is square root of 5. Okay, displacement is happening square root of 5. Force is a square root of 2. Square root of 2 into square root of 5, and then draw these two and calculate the angle between them, cos theta. I believe cos theta will be is base by hypotenuse. That is the cos theta. Okay, someone can calculate cos theta. One is I plus j, one is I plus j, this direction, and one is I plus 5j. I'm sorry, I plus 2j. That is the displacement. Displacement is along this direction, force is along this. What is the angle between them? Someone can calculate with these two vectors. If someone cannot calculate with these two vectors, force vector dot displacement vector is the net work done. That is I1 I1 plus 5, I'm sorry, 2 into 1, 2. 1 plus 2, 3 is the work done. Anyway, so idea is that person has to start with pseudo code only. Force vector dot displacement vector is the net energy calculation. Displacement, I can call it length vector also. Force vector, I know xi plus yj dot displacement vector, I don't know. I know this line is y, this line, if this is x-axis, then this curve is y equal to x square. This is the curve. If this is x-axis, then curve is y equal to x square. If curve is y equal to x square, what is the length vector? xi plus yj is the force vector dot length vector. That is or displacement vector. That is the net energy. No one knows it. Then we called it, okay, length vector is a vector representation of this line. What is vector representation of this line? Make it pseudo, means make the simplest. Then take a straight line. Vector representation of straight line from origin to x comma y is xi plus yj. Okay, and difference between a straight line and a curved line is here y by x is same, where here y by x is different at different point. In that sense, in that sense, the we have to bring, if I represent a straight line as a vector connecting two points 0 to 0 to x comma y, xi plus yj is the length vector. That is same as I plus y by xj bracket close into x. This is called length vector. Or xyyi plus j bracket close into y. This is also called length vector. Okay, now if it is y by x, it will be modified into calculus dy by dx. Y by x will become dy by dx, and into x will become dx. Please watch our previous video. So our length vector is I plus dy by dxj into dx. We took y by x because y by x is variable for the curve line. Now I have a vector equation for this curve also, that is I plus dy by dxj bracket close into dx. Dx is from begin point origin to point x comma y, then x 0 to x. That is the dx. That is the length vector. Now we can multiply. Force vector is xi plus yj dot d dot bracket I plus dy by dxj into dx. If I break it, then it becomes dxi plus dyj, or d of xi plus yj. Force vector dot d of xi plus yj is the network done. Mind blowing, amazing. Wherever, if okay, what about the length of this curve? If you have length vector, just calculate the magnitude, you get the length of the curve. Okay, otherwise length vector is I plus dy by dx j into dx. What about length vector of a line that is perpendicular to the x-axis? Okay, okay, what is the length vector of this line? Where the equation of the line is x equal to alpha. Alpha is a point where it is hitting the x-axis, that is alpha comma 0. Okay, in that sense, what is the equation of this line? Equation of this line as per your vector fundamental. Here dy by dx is infinite because if I proceed in x-axis, y will change in finite manner. In that sense, I plus dy by dx j into dx will not work. Then we started with the xi plus yj, right? I'll take out y now. Now it becomes y by xyyi plus j dy. Now it becomes dx by dy, dx by dy I plus j into dy, dx by dy. That is change in y. If I move along x y axis, change in y, how much x is changing? X is not changing. Dx by dy is 0. More or less, it is I dy. That is the length vector now. I dy that I have to place against the force vector to calculate the net energy. So net energy is force vector dot product with the length vector. If length vector is parallel to the y-axis and it is intersecting x-axis at alpha, the line equation is x equal to alpha. Length vector is I dy only. That's it. I dy. It is a vector. Xi plus yj dot product I'm sorry, j dy. J dy. In that sense, j will go away and I'm sorry, I will go away because there is no I here. It becomes y dy. Y dy from y is 0 to whatever. That is the net energy calculation. Mind blowing length vector. Length vector, wherever we need a displacement vector, I can place length vector. Wherever I need net displacement, I can calculate the magnitude of this vector. I get the length vector. Okay, in that scenario, the concept that is proceeding right now, the concept that we are pursuing is we will prove that our concept of length vector, that is I plus dy by dxj, I plus dy by dxj into dx, or dx by dy I plus j into dx, dx by dy I plus dx by dy I plus j into dx. This is the, I'm sorry, one is I plus dy by dxj bracket close into dx. This is a length vector. Another form of length vector is dx by dy I plus j bracket close into dy. This is also a length vector. Just multiply. If the displacement is required in a vector form, just use this vector form. Or if displacement is required in magnitude form, calculate the magnitude of this vector. This magnitude of this vector is 1 plus dy by dx whole square root dx. X is from begin to end. That's it. You get the length. This is called length vector. We are in a phase to prove that this length vector indeed works with the force independent, path independent force field. There also our concept that length vector is I plus dy by dxj bracket close into dx. It works there also. If it works there also, if it works there also, then length vector then can we prove it? Now, in order to prove it, the idea is happening that what is path independent force field? Path independent force field means if there is a force vector, because the force vector, one item is moving one position to another position. Okay, this is one item and this is force vector. Because of my force, this item is moving like this. Okay, there is a displacement in the item, means I am losing energy. How much energy I am losing? That is a concept that is called force vector. Okay, like down the line, there is a force vector because Earth has a force field. Down Earth there is an entity called Earth on which we are standing and sitting. So on the Earth has a force field that is going toward the center of the Earth. Okay, in that sense, Earth force field is considered as path independent. If I leave an item, it moves toward the Earth. means earth is making this item move. In that sense, if any item is moving, any mass is moving, then earth is working, earth is losing energy. How much earth is losing energy is dependent upon the begin point and end point only, and of course the force that is applied here. Force and begin point and end point, that is the earth is losing. Why I'm saying force is, if near the ground of the earth at the sea level, if item is moving 1 kilometer, then or 100 meters, then the earth is putting more force than item is moving 100 kilometers away from the surface of the earth, and there it is moving 100 meters, because their force is less. Force into displacement, net energy that will be lost by earth will be less. Here force is high near to the earth, here 100 kilometer 100 meter, force that will be applied by the earth will be higher. Now, in that sense, force into the, if force field is path independent, then begin point and end point will only work, not the path. Okay, in that sense, if I'm just leaving the item, it is coming from point A to point B. If it is coming from point A to point B, net energy that earth is losing is dependent only upon A and B, only upon A and B, not on the path. If we take a straight path, it is all right. I can make it move in a circular path also. If begin point and end point is same, I can put this like this. Okay, consider begin point and end point is same. Okay, it is not moving the way I was expecting, but it will move. Okay, in that sense, it took a circular path. It may take a straight line path, but the net energy Earth is losing is dependent only upon the begin point and end point. Not it is taking circular path or a straight line path or a staircase path. This is called path independent force field. Earth gravitational force field is path independent. In that sense, anyway, consider I have any force field that is path independent, and it is in xy plane only. It doesn't have z component right now. So force field can be represented as capital F, on top of it arrow mark. Capital F, on top of it arrow mark. That is called force field, vector field. Since it has only x and y component, it is F1, F1, F1i plus F2j. F1 is the x component and F2 is y component. In that sense, F1i plus F2j. Okay, F1i plus F2j is the F1i plus F2j is the force vector. Force vector is in xy plane. It has two components, I component and j component. In that sense, F1i plus F2j, F1i plus F2j. This is called force field. F1 is the ith component and F2 is the jth component. F1i plus F2j is the force field. Okay, now what is the net energy calculation? Force field dot product with our length vector. Length vector is I plus dy by dxj bracket close into dx. That will resolve into dx plus dyj. dxi plus dyj. That is I plus, that is d of xi plus yj, dot product with our force vector f1i plus f2j. This is the net work done. F1i plus f2j dot product with d of xi plus yj. This is the net work done. Okay, now concept is, I know that force field is path independent. Okay, then prove it that with my concept of the length vector, it will sustain the path independent concept. Through our length, through our concept, we have taken length vector at d. D means derivative of xi plus yj, where y is a function of x. Y is different for different path. What is path independent? What is path dependent? What is path? Path means, if a path means a line, path means curve. Curve in yx plane where y has equation in x, y equal to 4x. This is y equal to 4x. y equal to x, y equal to half x, y equal to x squared. So y and x relationship gives the line equation. I will not break the y. Let the y remain there only. Now I am talking about generic path. So net work done is from point A to point B. Force field dot the our length vector in generic manner only. So that is d of xi plus yj. Force vector dot d of xi plus yj. Force vector is f1i plus f2j. Okay, what is the concept of a path independence? That also can be understood here. If someone settle it down, it becomes f1 dx plus f2 dy. This is generic because y I have not broken. Whatever we are bringing in, it is for generic path. Let's proceed. f1 dx plus f2 dy. f1 dx plus f2 dy, where f1 is a ith component of force field. F2 is the jth component of the force field. F1 is the ith component of the force field. F2 is the jth component of the force field. But F1 is a function over x and y, and F2 is a function over x and y. F1 F1 can be y into full force field can be y cos xi plus y plus sin xj, where F1 is y cos x. It has y and x both. F2 is y plus sin x. It again has y and x both. But the force field ith component is F1 and jth component F2. Net energy is F1 dx plus F2 dy. If I say my force field is y cos x I plus y plus sin x j, then it becomes y cos x dx plus in bracket y plus sin x dy. If that is the scenario, then consider this is a pure integration. Consider it results into gxy. Whatever the integration we are making, it comes as gxy. Gxy is another algebraic equation in x and y. Makes sense? If I have y cos x dx plus y plus sin x dy, this integration will come in term of x and y only. If it comes in term of x and y, I can say the result is a function g over x comma y. The result is function g over x comma y. Okay, now this is the result. This result is generic because everything we are taking generic. Path is generic. I have not broken the y. Y is there, gxy. What is gxy? That is there we had stopped the previous day discussion. What is gxy? Okay, consider that I have consider that I have a xy plane. Hop, 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 hop. Consider that I have a xy plane. This is xy plane, and this is gxy. This hop, hop, hop. This is gxy. Okay, so this is a big gxy. Gxy means function over x and y. If I take like this is an asteroid. Asteroid, it fell from the sky. Okay, I think so. So, so this is a xy plane. If this is xy plane, then this is the asteroid that is hanging here. Now, why it is gxy? Now consider that if I see from the top, then it makes intersection on xy plane. It makes intersection on xy plane. Then it will create one region here. It will create one region out here. Okay, if it is xy plane, it will create one region out here. And on that region, we have set of x comma y. Okay, if I have a set x comma y, let's apply a function over x comma y. If x comma y is this, then as per the gxy is a function over x comma y. It can be sin x, cos x, whatever it can be. The way I had taken example, it can be something like 2x sin x, that is gxy. I'm sorry, it will be 2x sin x plus y square by 2, something like that. Now if you substitute x and y to some point, it will give you some value. That value, consider that is the height. Every x and comma y, apply gxy, it will give you separate heights, separate height points. You connect all the points, then it will become like this. connect all the points, it becomes a 3D shape. That is 3D GXY. Now we get through the generic fashion where we have not broken the y through our length vector, where we proceeded with the y. Otherwise, we could have gone with I plus dy by dx j bracket close into dx is our length vector. Dy by dx we would have calculated for a certain path, but we are saying, okay, if I have 2 points of the force field, 2 points in the force field, which can be connected by innumerous number of paths, but still length vector is same, I plus dy by dxj into dx. For a certain path, I have to change the dy by dx. Their dy by dx will be different for different paths. If I am not breaking the y at all, it is a generic path. In that sense, length vector is broken into dxi plus dyj or d of xi plus yj. Now, dot product with the force field, that is F1i plus F2j. That results in gxy. Gxy is the net energy calculation, Gxy from point A to B. That is the calculate the integration and limit of the integration is A to B. Now I have to substitute F1 dx plus F2 dy limit A to B. That is the energy calculation. F1 dx plus F2 dy comes as Gxy. Gxy A to B or Gb minus Ga, where A and B are point in x comma y. Okay, GB, G bracket open, B bracket close minus G bracket open, A bracket close. GB minus GA to B. If that is the scenario, GB minus GA, whatever it is, GXY is a 3D shape. If GXY is a 3D shape, then this is called Z value, height value. GXY is also called Z value because we took different Z value and connected all the point, and that point, we connected all the point, and that point become a 3D shape. This is called Z value. If I have net integration as Z, then Z from A to B, Z value at XY point as A, at XY point as B minus Z value at XY point at point A. That is the net energy. I believe it makes sense. If I This is called potential energy function GXY or Z. Z is a potential energy function because if I have potential energy function, then if some this is potential energy, if item is here, it carries one potential energy. If item is here, then there it carries potential energy that is less. How much potential energy it lost? It lost. That is the work done by the earth, and it depended upon the net height from the earth only, not on the path it took to come from here to here. That is like that. Same thing is gxy or z. Z limit is from A to B. Height. Z means height. Height when B height at point B, height at point B, and height Z value at point A. Z means GXY. GXY, GXY is a function over X and Y. But this function value, when I take point B, point A and point B, this point is a kind of some, if I take this XY plane, this point is A comma B, and this point, I'm sorry, this point is X comma Y, and this point is X comma Y. In that sense, GXY X1 Y1 to X2 Y2. If someone sets it, he gets the net energy. Now consider GXY is Z value. Consider GXY is Z. Now let's go with different interpretation. Right now, leave this limit and focus on GXY. GXY function over X and Y in 3D, it is also called Z value. Gx function over X is also called Y value in 2D. In YX plane, Gx is called Y. In 3D, Gxy is called Z. How we get Z? Okay, Z equal to integration of dz. Make sense? Z equal to integration of dz. That is Z. What is Z? That is a question. Now consider this is 3D. Okay, if this is 3D, then if this is a 3D shape, What at this point, what is z value? This point I know, if I go in xy plane, and this point if I just see down, there is it will hit xy plane, and that point is called x1 y1. Understand? Consider this is xy plane and this is a 3D shape. In this 3D shape, I have a point here, and this is z point. This point is z point or fxy. If I just go down and hit the xy plane, it will intersect xy plane at a point called x1 y1. Consider like that. What is the tangent at this point? Oh, sorry, I'm sorry. What is the z value at this point? Z value at this point, how we can describe z value at this point in other terms? Okay, let's think that z value here, the z value. Okay, I believe I'll go in. I believe it is all right till here. Okay, now let's consider this is xy plane. This is xy plane, and this is x-axis, and this is y-axis. This is y-axis, this is x-axis, this is origin. Okay, now I keep y-axis constant and I move this. Okay, now this is the height I am seeing. This is called z. This now this is x-axis, this is y-axis, this is z-axis, this is x-axis, this is y-axis. I'm sorry, I'll take from my side. This is x-axis and this is y-axis. This is origin. Now this is xy plane. I keep y-axis constant and I lift like this. At any moment, what is z? Here z is high, z is low, z is low. This is x-axis. At any x, what is z? Then at any x, z is dz by dx into x. When x equal to x1, then at this moment, dz by dx is constant because it is a flat line. Dz by dx into x1 is the height at point x equal to x1. If this point is x2, then height is dz by dx into x2. Makes sense? Now keep the x-axis constant and lift the y-axis. Now tell me at any point x1, y1, what is the height? Now just leave it like this. Keep the x-axis constant and lift the y. Now in that sense, now this is y-axis. At any point y1, what is the height? That is dz by dy into y1. Now, if I keep y-axis constant and lift it like this, and then keep x-axis constant and lift it like this, see z is growing. If I keep the y-axis constant and lift like this, then anywhere, z is like this. Everywhere z is constant if the x is constant. This is x-axis. If I take any x along this x, z is constant. If I grow in x, z is growing. But if I grow in y, then z is not growing. Okay, this is the concept. Now I keep the x-axis constant and just watch the z value. Z value is growing. If I'm moving the, now see the end point here, z is grown to high extent because now I keep the x-axis constant and making the y go up. Now this is xy plane. In the xy plane, at the end, this point is x1, y1. This point here, height is very high. At any point x1, y1, what is the height? Then we are adding both the height. If I keep x-axis constant, then height is dz by dy into y1. If I keep y-axis constant, then height is dz by dx into x1. If I do together, then height will be dz by dx x1 plus dz by dy y1 as per the basic fundamental of a flat surface. Okay, then what is your equation? Now, if this is a 3D, and if I have this is xy plane and this is any point z. Okay, now I take the tangent plane at this z point. If I take tangent plane at this z point, what is the equation of the tangent plane? Okay, the tangent plane equation at this z point will go down on xy plane, and there it will hit a point on xy plane, that is x1, y1. The height z at any moment is z equal to dz by dx x1 plus dz by dy x2, where x1 and dz by dx x1 plus dz by dy y1, where x1 and y1 is a point on xy plane. From there, x1, y1 is a point on xy plane. From there we are going up, and it is hitting a point here that is called z. Okay, now z equal to the height is z equal to where it is hitting a point x1, y1 is dz by dx x1 plus dz by dy y1. Okay, so we can say that any z is dz by dx x plus dz by dy y. What is dz by dx x and dz by dy y? Now, for any point z, the equation is z equal to dz by dx x plus dz by dy y. What is x and y is, from here if I go down and hit the xy plane, at that moment the x and y is x comma y. In that case, at any point here, if I try to get the z is the height. What is this z? This z is dz by dx into x plus dz by dy into y. I understand that it, this z you are talking, that is the height. If I go here and it hits the xy plane here, on the xy plane, what is the x comma y? That is there dz by dx, x is the hitting point on the xy plane, plus dz by dy hitting point y on the plane. Then that is the z. What is dz by dx, dz by dy? At this point, if this is point I am taking, then dz by dx, at this point, let cut this into xz plane. Let cut, if I am talking about this point, let cut this xz plane. If I cut this xz plane, there will be a flat surface will come into the picture. If I cut this in xz plane, consider this is a sphere. Consider this is a sphere. I take this point here. I make a cut in xz plane. If I make a cut in xz plane, then it will come like a circle. If I make a cut in yz plane at any point z, it will come as a circle. Dz by dx in xz plane, and this is the point z in xz plane. This is the point z in yz plane. Dz by dx, dz by dx, that at this point, what is dz by dx? That is a tangent. Okay, dz by dx in xz plane, per unit change in the x brings how many unit of change in the z? Dz by dx. But if I cut in xz plane, everywhere dz by dx is different. Okay, calculate at point x1. This is what is said. Z, if I am trying to calculate z, it is gxy. What is z? At any point, if this is xy plane, what is z? That is the height. Z is dz by dx. Means at this point, take xz plane and calculate the dz by dx. Then take yz plane and calculate the dz by dy. If you know at this point what it is, because everywhere dz by dx will be different in xz plane. Everywhere dz by dy will be different in yz plane. At point x, if I take any random point x comma y on the xy plane, and from there I draw a vertical and it hits here, then at that point what is dz by dx? And at that point what is dz by dy? Dz by dx x plus dz by dy y is the height. Dz by dx is variable dependent upon x. That's why it is algebra. Algebra will take care of it. Dz by dx will be an algebraic equation. Dz by dy will be an algebraic equation. That algebraic equation, dz by dx into x plus dz by dy into y. Thank you very much. Now the question is arising is that in energy calculation, we said that f1 dx plus f2 dy brings gxy. Gxy I am taking at z. Z equal to integration of delta z. Z equal to integration of dz is z only. Now z I know. Z equal to dy by dx x plus dy by dx y. What is delta z? Z equal to integration of delta z. What is delta z? delta z means if z equal to dz by dx x plus dz by dy, that if someone sees, if, okay, thank you very much. Now consider this is a z, this is a point z, and if this is a point z here, and if I have a tangent surface here, there is a surface, flat surface, and at point z, this is a tangent surface. Everywhere tangent surface is different. If I take this tangent surface, looks like dz by dx into x plus dz by dy into y is the equation of the tangent surface. Makes sense because we started with the like that one. If you remember, first we shifted keeping y-axis constant, then we shifted keeping the x-axis constant. In that sense, the equation of this flat surface is dz by dx x plus dz by dy into y. Okay, now if I say at any point z is the height and z is dz by dx plus dz by dx into x plus dz by dy into y, we are more or less we are talking about a flat surface equation that is tangent at that point. Okay, if that is the story, now forget this 3D, forget the 3D, and let's talk about this flat tangential surface at any point z or any point x comma y comma z. That is the point. At that point, this is the tangent surface, and its equation is dz by dx into x plus dz by dy into y. Now, this is the point z, x comma y comma z, where it is tangent. Now, if in the along the tangent, if I move delta z little bit in height, or or if this z point has intersection on xy plane at comma x comma y, if I move little bit along x axis, that is x plus delta x, and if I move along y axis little bit, that is y plus delta y, I will get another point at x plus delta x and y plus delta y. Then how much z will move? That is called delta z. If I move along x-axis delta x, if I move delta y along y-axis, delta x along x-axis, delta y along y-axis, then how much I have to move, then how much z would move? Make sense? What I'm trying to say is that this shape, this is xy plane, and here it is x comma y. From x comma y, I go and hit here, that is z. Okay, in x comma y, instead of x comma y, I take another point, that is x plus delta x comma y plus delta y. That will go and hit another point here. This point and this point, the distance is called delta z. Delta z, z equal to dx by dz by dx x plus dz by dy y. What is delta z then? Then delta z will be dz by dx delta x plus dz by dy delta y. It can take bigger form as per the Taylor series. We are taking the first order right now. First order in the sense that for 3D shape, for the 3D shape at any point x comma y comma z, if I have to find the equation of a tangent surface, that equation is z equal to dz by dx into x plus dz by dy into y. Now, if I talk about delta z, means how much z moved when I move delta x and delta y along xy plane, we are talking about the delta z in this surface, not on this, but it's all right. Right now, it is all right. So delta z equal to dz by dx delta x plus dz by dy delta y. Now, in the energy calculation, we had f1 dx plus f2 dy equal to gxy. Gxy I took as z. Z equal to integration of delta z. Now z is gxy. Gxy is equal to integration of delta z. Delta z is dz by dx delta x plus dz by dy delta y. Delta x and delta y, I can replace it as delta z equal to, but I wanted dz, integration of dz. If I represent delta x tends to 0, if I say delta x and delta y tends to 0, then all will become dz equal to dz by dx plus dz by dy dy. Hope. Then our equation z equal to integration of dz becomes z equal to dz by dz dx plus dz by dy. It looks funny. If I break it now, dz by dx plus dz by dy dy. Or let it in the form of delta z only, it will be more clear. Z equal to integration of delta z. Delta z is dz by dx into delta x plus dz by dy into delta y. Same thing can be written as dz by dxi plus dz by dyj dot product with delta xi plus delta yj. Same thing. Dz by dx delta x plus dz by dy delta y is same as dz by dxi plus dz by dyj bracket close dot product with delta xi plus delta yj. Now I transform delta x and delta y into dx dy because it is infinitesimally small. Now it becomes delta z becomes dz by dxi plus dz by dyj dot product dxi plus dyj. Dxi plus dyj is our length vector only. Okay, in that sense, force field is dz by dx f1 and another is dz by dy is f2. Now f1 equal to z is gxy, f1 equal to dgxy by dx and f2 equal to dgxy by dy. Makes sense? Z equal to integration of delta z or dz. Delta z is dz by dx delta x plus dz by dy delta y. It is same as dz by dxi plus dz by dyj dot product delta xi plus delta yj. Okay, in that sense, if I take delta x delta y tends to 0, it becomes dz by dxi plus dz by dyj dot product of d of xi plus yj. This is exact equation for the energy calculation F1 I plus F2j dot product of d of xi plus yj, that is F1 dx plus F2 dy. This proves that if we start taking the generic path, we did not break the y. Then in that sense, F1 equal to dz by dx and F2 equal to dz by dy. Z is gxy. That is the end result potential energy function I have got. So F1 equal to dgxy by dx and F2 equal to dgxy by dy. Make sense? Now, this is the called path independence. Path independence in the force field. If I say my force field is path independent, then whatever the potential energy we are getting gxy, then dgxy by dx should be F1 and dgxy by dy should be F2 because we took everything in a generic fashion. If we take in generic fashion, then F1 force ith component of the force field has to be the net energy calculation gxy dgxy by dx. F2 have to be dgxy by dy. If it does not happen, then force field is not path independent. If it satisfies this, because we started with the satisfaction only, we did not break the y. We took for all possible paths. In all possible paths, this is the homogeneous. It is called homogeneous scenario. This is the homogeneous scenario. If I take all possible paths, then homogeneous scenario is dgxy by dx should be f1 and dgxy by dy should be f2. If it is not like this, then it is breaking our the beginning idea that was generic path. If it is like that, then our generic path concept would work and this force field will work for, I am not saying this force field will work for only for, it dependent only upon two paths. This proof what we are giving is force field is same for all paths. Okay, one is force field is dependent on only on the begin path and end point. This is the right law fundamental. So our length vector, we are saying force field is same for all generic paths because we did not break the y. Okay, please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code. We'll proceed in the mind-blowing length vector again.